Hey guys, Tristan here, and today we'll be talking about the types of inheritance. The first type of inheritance we usually like to talk about is the autosomal dominant. And a dominant trait is when one of two alleles are expressed, meaning that the dominant allele overrides the non-dominant allele. The example we'll be using today is hair color. George and Georgina have 4 kids. So if George is homozygous black hair, in which homozygous means that he has both alleles that are black, and Georgina has blonde hair, then all 4 kids have black hair, then black hair is the dominant trait for hair color. In this table, which is a Punnett square, we see 4 outcomes of George and Georgina mating, and each represents a child. And all 4 are heterozygous dominant, but they are still dominant for black, so they all have black hair still. Which leads us to kind of like our second point-ish, which is homozygous and heterozygous dominant. When you're homozygous dominant for a trait, that means that both alleles are the same dominant allele. When you are heterozygous dominant for a trait, that means that you have one dominant allele, the one that is expressed, and you have a recessive allele hidden away, and it acts like a carrier. You are able to pass on either allele to future children, which leads us to our second trait, or the second mode of inheritance, which is autosomal recessive. A recessive trait is when both alleles must be the same in order to be expressed. The example, once again, will be hair color. Bob and Bobalina have 4 kids. Both parents are heterozygous dominant for black hair, which means that they each have one black allele and one blonde allele. 3 of their children end up getting black hair, which one of them is homozygous black and 2 heterozygous black. And the 4th ends up with blonde hair. The blonde hair in this situation is a recessive trait for hair color. And once again, this is a Punnett square where this could be Bob and this is Bobalina, and this shows the 4 outcomes, which each outcome represents one child. So child 1 would be homozygous black, BB uppercase. Child 2 would be heterozygous black, which is the blonde. The blonde has one recessive allele. Same with child 3. And child 4 has 2 recessive alleles, which makes the child blonde. The third mode of inheritance is incomplete dominance. Incomplete traits are when both alleles are expressed at the same time, thereby the resulting character trait being an intermediate expression of both alleles. Which that means is when 2 organisms mate, the character traits mix in together. And so the example we'll be using is a red flower mates with a white flower, and the result are 4 pink flowers. So the red is homozygous uppercase R and white is lowercase r, and when they mate together, all 4 outcomes are pink. So now this leads us to our 4th. What happens if it doesn't mix? The codominants. Codominant traits are observed when 2 different alleles are both expressed simultaneously, although not creating an intermediate like incomplete dominance, where neither allele is recessive. The example once again we'll be using is flowers. So a red flower will mate with a white flower, and instead of mixing together become pink, it results in 4 flowers being red with white polka dots. In this case, uppercase RR is red, uppercase WW is white, and RW is a red flower with white polka dots. So they mix, although they mix in together, each trait or each color, you can see both of them. So you see red as the main color and then white polka dots, or the opposite. And the 5th mode of inheritance that we usually talk about is sex-linked inheritance. This occurs when the trait in question is present on the chromosomes that determine the sex of a baby. The example we'll be using is once again Paul and Paula. They have 4 kids, and Paula is a carrier for colorblindness, while Paul is healthy. 2 of the 4 kids are girls and healthy, however they have 2 boys, one of which is colorblind. The trait was passed on through sex-linked inheritance. Through this, what happens is the trait for colorblind is located on the X chromosome. Girls have 2 X chromosomes, while males have 1 X chromosome and 1 Y chromosome. In this case, XY is Paul and XXC is Paula. Child 1 is a carrier for colorblindness because colorblind is a recessive trait, and so she's a carrier. Child 2 is healthy, and child 4 is also healthy. Child 4 is a male, child 2 is a female. However, child 3 is colorblind, and because Males only have one X chromosome. That means that you only need one chromosome that is with color blindness just to get colorblind. While girls with two, they need two chromosomes with colorblind trait to get color blindness. That's why it's sex linked. Thank you guys for watching. This is a little bit longer than it usually is, but have a great day.